Yes, laws of friction. Number one is what? Yes, force of a friction is proportional to normal reaction. Normal reaction, an object if the weight of the object is mg acting downwards, normal reaction is upwards. This is normal reaction by virtue of weight. Your observation is, if there is a truck without load on, say, a red light crossing, when the light turns green, it takes no time for the truck to move if it is unloaded. If it is a loaded truck, then it takes a lot of effort because engine needs more power and it takes more time also. Why? What is the difference? Unloaded truck and loaded truck, what is the change? Weight is different. Loaded truck has more weight, more reaction. This is one. Second, normal reaction can be by virtue of muscle power. Like, it is easy to move the two if there is a soft contact between the two. But if I press it, I am applying more force, so normal reaction is also more. Now it is difficult to move. Agreed or not? What is the change? In the previous case, normal reaction was less. In the second case, normal reaction is more. This normal reaction is not by virtue of weight, it is by virtue of muscle power. So when you hold something, grip something like a chain, rope, something, then what counts is normal reaction is because of your ability to hold it tightly. Then the normal reaction is by virtue of a muscle power. Competition questions. Normal reaction, one is by virtue of a weight, second is by virtue of your muscle power. So whatever it is, frictional force is proportional to normal reaction R. In terms of magnitude, for an object lying on the floor, magnitude of R is equal to magnitude of mg. So law number one is force of friction is proportional to normal reaction. 1. Law number 2. Direction of friction is opposite to tendency to move. That is, if there is an object at rest, you apply a force applied, friction will oppose it. This is experiment number 1. 2. Same object, now you apply force from the right side and you try to move the object towards left, friction is towards right. So frictional force is opposite to tendency to move. Time with you is 3 minutes. Law number 1 and 2. Law number 3 is what? Force of friction is independent of area in contact. Force of friction is independent of area in contact. That means what? Same example. Whether you place the object like this or this, the frictional force remains the same. That means you need to draw two diagrams. Whether you place the object like this, where area of contact is large, or you place the object like this, where area of contact is less. In both the cases, frictional force comes out to be same. Law number 3. 4 is what? Yes. Law number 4 is what? The law is friction depends on material of surfaces in contact. Friction depends on material in contact. That means it is a surface phenomena. Friction is a surface phenomena. If you have a rough surface, you can paint it and you can make the surface smooth. That is why a metallic object, you give it only the surface treatment. In case you want to make it smooth, then you give only the surface treatment. That is why it is a surface phenomena. Materials in contact, material 1 and material 2, wood on wood, wood on plastic, wood on paper. For a road, yes. Tire, tire is what material? Rubber. Concrete, floor. So, for vehicles, tire and concrete. Material, 2 materials, rubber and concrete. So, there is a value of a friction. So, friction depends on material. So, frictional force is proportional to normal reaction, but if the normal reaction is the same, still the friction comes out to be different. Reason is, there is one more parameter, nu. This is termed as coefficient of friction. The rest of the chapter deals with nu only. So, what counts as weight, that is material 1. What is the weight of the object? This is one object, place another object. If weight is more, normal reaction will be more. Second parameter is, this is plastic, this is paper. Friction between plastic and paper is different than between, say, plastic and plastic. That means in the two cases R was same, but materials in contact are different. That is why it depends on what materials in contact. Coefficient of friction, nu. Time with you is 3 minutes. 3 minutes to write. B part deals with what? There are 4 laws and you have to perform 4 experiments. Experiment number 1, to confirm law 1. Law number 1 was, yes. Law number 1 is what? Experiment number 1 to confirm law number 1. What was the law? Friction is directly proportional to normal reaction. So, we will perform one experiment. In the lab, there is a experiment table on which you have one side, there is a pulley, some weight, and there is a pan on the other side. So, there is a friction between the block and the floor. If you place some weight here, 1 kg, 2 kg, 3 kg, at some stage this object will start moving to the right. So, suppose this object, this is mass m, this is 1 kg. It just starts moving when you place how much weight? 1 kg. This is one experiment. Now we will increase the weight. This one, M, another object, same mass M. That means what? Previous case was a truck without load. Second is a truck with load. Now, what is your observation? The effort required to move this will be more or less as per the law. As per the law, this mass is doubled. Normal action is also doubled. As per law, the weight required to move this should also be doubled. Let us see. Try. One part, 1 kg. No movement. More effort is required. Place one more, 1 kg more. 1 kg plus 1 kg. It is 2 kg. This 2 kg, 2 kilogram weight, effort. What was the effort here? 1 kilogram weight was sufficient to move it. Now the effort required as per the experiment comes out to be 2 kilogram weight. That means what? Friction in the second case is 2 times in the first case. What was the normal reaction in the first case? mg. In the second case it is 2 mg. Normal reaction in the second case is 2 times. Rest of the parameters remain same. That means it is confirmation of what? Friction is proportional to normal reaction R. In the first case R1, first case F1 is proportional to, second case it is R2, F2 by F1 is equal to R2 by R1. How many times? 2 times. Friction in the second case comes out to be how many times in the first case? 2 times. Time with you is 3 minutes. Second law. Experiment number 2 to confirm second law. What was the second law? Yes. Friction is? Yes. Second law is what? Direction. Second law deals with the direction. The law is, yes. We just go through the statement law 2. Direction of friction is opposite to tendency to move. First case, experiment number 1. You apply force to the right, applied force is to the right. Friction, opposite. Now change the position of the pulley. Shift this pulley from the right side to left side. Again apply weight. Now you are applying force to the left. Still the object is not moving because the frictional force is towards right. 1 minute to complete. 1 minute to complete. Experiment number 3. To confirm, yes, to confirm law number 3. Law 3 is, yes, friction does not depend on area in contact. We take 2 blocks, each of mass m, and suppose it moves with a weight 2 kilogram weight. There is some area in contact A. Now the arrangement is, there are 2 masses connected by a string and the string passes over the pulley. Now the area in contact is A plus A. Yes. Area in contact in the second case is how much? 2A. Again, we add weight. Half kg, no movement. 1 kg, no movement. 1.5 kg, no movement. 2 kg, yes. When this is 2 kg, the object just starts moving. That means the same result and as in the previous case. Area in the first case is A. Area in the second case is 2A, but the force required to move, that means opposing force, friction in the two cases remains same. Friction, as per the result, friction does not depend on area in contact. 2 minutes with you to write. Experiment number 4 to confirm law number 4. Law 4 is what? Yes. Friction depends on material of surfaces in contact. Experiment number 1. Say this is one table of any material, say wood, and a block. 1 kg object, material is wood. Again, you perform the same experiment. Pulley, rope, and put up some weight here. 100 gram, 200 gram, 300 gram. Suppose it moves at say 1 kg. Suppose. This is experiment number 1. Material is wood. Suppose this is also wood. This material is wood and wood. Experiment number 1. Experiment number 2 is everything remains same, but you have the material different material. It is iron. 1 kg mass remains the same. Normal reaction mg remains the same. Material is different. Iron. And when you perform this experiment, observation is it moves at half kg. What is the change? Mass same, weight same, everything same, but now it is iron and wood. So frictional force depends. Friction depends on materials in contact, rather on surfaces of materials in contact. Time with you is 3 minutes to write. 3 minutes to write. Question is, if these two materials are 1 kg and 1 kg, 1 kg and this table is also iron, then it will depend on nu between iron and iron. That is our next question. There is a table given in the next question. We will discuss two materials in contact.